Hi, Assalamualaikum and hello to Dr. Arif. We are from Group 1, consists of me, Ahmad Afif Jazimin, Lim Kai Peng, Lau Jiro and Muhammad Nazri. Of course, Thermodynamics and Mechanics of Material Laboratory. So we are going to present our experiment 7, which is estimation of heat capacity and entropy generation. The first part is introduction. The objective of this experiment to estimate the heat capacity of different metals and to estimate the entropy generated when these metals are dropped in a container containing water. Our scope of this experiment: number 1, use and analyze three different types of metals, which are iron, aluminium and copper. Number 2, assume there is no heat loss when transferring the metal from one container to another container. Number 3, the system is stirred continuously throughout the experiment. And the last one, number 4, the data will be recorded every 20 seconds interval until the system reaches its thermal equilibrium state.
I'll present about the theory. Specific heat capacity is the amount of heat energy required to raise the temperature of a unit mass of the substance by 1 degree Celsius. The general formula that applies specific heat capacity is Q equals to mc times delta T, where m is the mass of the substance in kg, c is the specific heat capacity of the substance, and delta T is the temperature change. The higher the specific heat capacity, the slower the substance to heat up and cool down, as it takes up much more energy to change its temperature. Entropy is the measure of the amount of disorder of a system or energy unavailable to do work. As we all know, entropy change occurs spontaneously, and entropy is always increasing. For this experiment, we apply that the formula delta S equals to mc times ln T2 over T1, and delta S total equals to delta S metal plus delta S water.
Next part is experimental setup. Based on the figure 1, we have a thermometer, hot plate magnetic stirrer, aluminium foil, and then we have metals, which are aluminium, copper and iron. And then we have beaker, and the last one we have scale to record the mass of metals.
Step 1. Copper, aluminium, and iron metal were weighed by using weighing scale and recorded. Step 2. 100 milliliters of water was poured into two beakers. Step 3. The initial temperature of the first beaker was recorded. Step 4. The second beaker filled with water was heated by using a hot magnetic stirrer, and copper metal was slowly placed in the heating water by using a metal string until it was fully submerged. Step 5. The water with a fully submerged copper metal was heated until 80 degrees Celsius. The temperature of the water was assumed the same as the temperature of the copper metal. The heated copper metal was taken out by using a metal string and immediately transferred to the first beaker. Step 7. The first beaker was covered by using the aluminium foil. The temperature of the water was recorded for every 20 seconds by observing the thermometer until it reached a constant temperature. Step 9. The water stirred the water stirred throughout the process to ensure even heat distribution. Step 10. The experiment was repeated by using aluminium and iron metals.
This is the result table we obtained from the experiment. To achieve the objective of this experiment, the specific heat capacity need to be determined. This is an example on calculating the specific heat capacity of copper. The below shown the significant values that required to find the specific heat capacity. Note that the mass of water is constant throughout the experiment. By substituting the values into the equation of equality, the specific heat capacity of copper is 0.4409 joule per gram degree Celsius. After we obtain the specific heat capacity, we can find the entropy generated by metal and water. After we obtain the entropy generated by metal and water, we can find the total entropy generated by copper by simply adding up the two entropy. For both the aluminium and iron metal, they apply the same method to find their measured specific heat capacity and total entropy generated. Hence, the calculation will not be shown in this video. You may pause the video to go through the calculation. The table shown below is the summary of specific heat capacity and entropy for each metals. From the table we can see that the total entropy for copper is the highest, while for iron is the lowest. The table shown below is the percentage error between the measured and theoretical specific heat capacity. When we calculate the percentage error for specific heat capacity, we notice that iron has the highest percentage error. In order to minimize the error, here are the sources we think it is the reasons that lead us to the inaccurate data record. The first error of our experiment is the container was not stirred throughout the experiment. We can either choose to reduce the size and the volume of the container or restir the container. Next, the experiment was done in an open area. In order to reduce the heat loss, we are recommended to switch off the fan and insulate the system with aluminum foil. Other than that, some of the thermometer is defected, so we suggest to check the condition of the thermometer before using. Lastly, the contaminants and impurities of metals. To remove the contaminants, we can use soap and water to clean the metal surface. For iron, we can use sandpaper to polish the surface. In order to improve our accuracy of data, stirring the water is essential since it allows the heat to be distributed evenly in water. Besides, transferring the hot metal quickly into the water will help us to reduce the heat loss to the surrounding as well before any reading is taken.
Conclusion. From the result obtained, all of the entropy are positive value. This proves that the theory about entropy is always increasing, delta S larger than 0. This shows that the process is irreversible process as the entropy obtained are not equal to 0. To improve the accuracy of the data obtained, we could use smaller beakers of containers to prevent reading error. Secondly, stir the water in container right after the hot metal is put into the container to ensure even heat distribution. And lastly, check the condition of apparatus before the experiment to prevent inaccurate reading. Safety procedure. Firstly, personal protective equipment PPE. We have to wear lab coat to prevent the splashing of hot water on hands or body. Closed-toe shoes. This is to prevent the potential injury caused when handling the metals. Gloves. This is to avoid scalding when undergo the experiment as hot water is applied in this experiment. Secondly, handle the apparatus carefully. We have to handle the thermometer carefully to avoid it from breaking as the mercury in it is dangerous. Lastly, we have to report any injury to the lab assistant to get the first aid treatment immediately if there is any injury happens.
This is our reference throughout this experiment.
This is our appendix, which are the data obtained during the experiment. Thank you for watching.